So to do these types of problems, the key thing is to recognize that there are some standard identities here. And those you do need to know. So sine 2 theta is 2 sine theta cosine theta. And then cosine 2 theta is 2 cosine square theta minus 1. And that's what we're going to apply that here. So that's 2 cosine square x minus 1. And we'll see what kind of simplification happens. Sometimes it may work, sometimes it may not. But that you have to look, keep an eye out. This drops out, that certainly helps. And I'm going to move this term to the other side. And then I'll factor the largest common term. So this is, I'm looking for solutions to this. That would happen when cosine x is 0, which if we kind of use the unit circle in the r theta plane, that's going to happen when, so if we look at any point here, cosine, I should say r, x, y, so the x, not to confuse with this x, the x is the theta value, the cosine theta value here. This is, you may know this from the unit circle. So we're looking for when this whole thing is 0, which would be here at pi over 2. And then again when we come back to 3 pi over 2. So those are two values. Next we're looking for when cosine x is equal to sine x. And that's going to happen at 45 degrees or pi over 4. The first quadrant, and then here, because they both have, they're both equal at this point. And this is going to have minus 1, minus 1. So that's going to happen at pi over 4, and then add pi to that to get to this point, which would be pi over 4 plus pi, which is 5 pi over 4. So these are the four values for which this expression will be equal to 0, which is equivalent to the original. Look at the answer choices. This matches with choice C.